My presentation today is going to be autobiographical, so sample size of 1, don't take it too seriously. So, who am I? I'm a data scientist with Nanotech Galaxy. We do machine learning algorithms to analyze radiological imagery. So we use machine learning to predict diagnosis that would have been done by a radiologist if he was looking at an X-ray, for example. So quite complicated stuff. Now, 6 months ago, I was a project manager for a development company. Now, one might think, how the hell did I get to become a data scientist from a project manager? Now, one caveat is that I'm actually a mathematician, so that helped a bit. But from the time I did my degree, I spent 2 years working in a completely non-technical industry with people who do not know how to format an Excel spreadsheet, let alone compile a machine learning model. So why did I hack? Why did I decide to do it so quickly? Why did I hack my career? Now, I had a bit of a falling out with the academia. When I was back at school, I've always been called the smart but lazy student. I've always done my assignments at the last moment. I've never been, well, I've been some of the teachers' pet, but not all of them, definitely. So when it got to university, it got worse. So I suddenly realized that, wait a minute, I don't actually, I'm not in love with what I'm doing. I'm not particularly excited about half of the subjects. I'm falling asleep at 10 a.m. even if I had 10 hours of sleep the night before. So even though I'm a big fan of maths and a big fan of science, I decided not to do a PhD when I graduated. I realized that I wasn't going to survive it. And as I'm seeing from a lot of my friends doing their PhDs, they're just barely surviving it themselves. So I decided to become a data scientist about a year ago when I watched a TED talk by Jeremy Howard, the CEO of Analytic, who are actually now our main competitors at the moment. And I was really inspired. I finally realized that my long-standing interest in the sciences and in neuroscience as well could be made into a career, which is AI research, machine learning. But how do I actually do that? When I started researching into degrees, I realized that, well, it's going to take me 1 year for a master's and 3 years for a PhD if I get the funding or if I get accepted. I quit my job November last year. If I were to go for a master's degree, it would have cost me £28,000 as a non-EU student, and I would have started in November this year. Not now even. So I would have still been in my job, which I hated, not knowing what my future is, suffering from uncertainty and facing a large bill from the university as well as the living expenses. So I decided not to do it. I quit my job and I saved some money and I just devoted 6 months to learning, to teaching myself to become a data scientist as quickly as possible. Why would this even work as an approach? Now, because everybody knows that we've got these universities, everybody wants to go and do a degree because that's what people normally do. Well, from practice, one might suspect that, in fact, a lot of social systems are hackable. You don't generally have to follow the rules. If you actually become a bit scientific and a bit of a statistician, you can take calculated risks and calculated inconveniences that other people decided not to take or were too afraid to take and actually find a much faster route. Now, why does our society support higher education in general? The standard answer to that is because, well, there's social pressure, because you're expected to do a degree. But that wasn't the case 100 years ago. Nobody graduated from school like in the 19th century. What you had was people transitioning through labor, people transitioning through family connections, or pure talent and being noticed. Why do we now do our degrees? Well, one might say that, well, we need a more structured approach. We need to actually, and this is valid, we need primary education, we need children to be guided into their careers and have some standardized base from which to build upwards. But an economist called Robin Hanson also has another idea specifically about university and higher education. It's not about social pressure, it's about social signaling. It's about prestige. It's like wearing a Prada bag or Louboutin heels for girls. So what you're actually doing is by having a degree, you're telling the employers that, well, you've been good enough to get into this university. You've been, it's like a label that is easy to validate and is easily noticeable. So this is why the new equilibrium is that generally people go into higher education now. We don't just try to transition into doing things straight after school or even after primary school as would have been done even 50 years ago. But the cost of that is increasing. So if you look at the cost of education in the States, between 1980s and 2014, it has skyrocketed. The average student is now facing an insurmountable debt if their family obviously isn't rich enough to pay for them. So this situation looks a bit like the tulip trade in Amsterdam. So the market got so much out of control. We've got a bubble here, quite obviously. And because we've got a bubble, clearly it's not a very good idea to buy into that. There must be another way. You're not in an absolute need of something. But let's say, what if, in fact, education gives you some value? What if it's not just about social signaling? Well, there is some evidence against that. There was two researchers called Schmidt and Hunter did a meta-analysis of the best predictors of success of an employee after interviews, as per employer. Now, the best predictors are obviously work sample tests. How well have you seen them do their job? IQ, because the higher the IQ, the faster a person would generally learn. Employment interviews, but just the structured ones. The unstructured ones are far way down the list. So if you have a standardized approach, if you ask everybody the same questions, you can weed out the people who are worse and pick out the people who are better. Job experience, number 14. The fact that you have 10 years of work experience doesn't say much about how good you're going to be at your job, even in your existing industry. And number 16, we've got years of education. It explains 10% of the variance in job performance. So really, if you have spent 5 years after university on PhDs and postdocs, it really doesn't say much about you in real terms. So even if you might get an easier time finding a job, you're not going to get an easier time keeping a job. And moreover, it doesn't guarantee that you're going to find a good job or a job that you're going to enjoy. This is something that's going to be controlled by other factors like how intelligent you are, how persistent you are, how much have you practiced, 10,000 hours. Has anybody read Malcolm Gladwell's Outliers? There you go. So it's not about intelligence alone, it's not about practice alone, but the two together make a winning recipe, and they do not depend on where you went to uni. Obviously, the two are correlated, so if you've got persistence and intelligence, you would have gotten into a better uni, but maybe you just lucked out. Or maybe you gamed the school's educational system, which is very different from actual industry, and that allowed you to get good grades and get into a good university. But writing an essay a week to a predefined set of criteria isn't the same as putting software into production at a 2 weeks notice, and you don't even know what it's going to be yet. So really, betting on education isn't a very good idea in general. assuming you know what you're doing though. Ouch. So what did it mean for me? First of all, as I've already said, I didn't want to pay 28K on tuition fees alone. These are the real figures, by the way. This is how much Masters in Machine Learning and Statistics costs at UCL, and also a similar degree at Imperial. They all cost about £28,000, and they are also few and far between. If you want to go for a boot camp, there is one, i.e. private education, which is more practically oriented. There are a few, but there's, as far as I'm aware, there's only one decent course in London, and they take 20 people at a time, which is, which is the General Assembly course. If you've got a PhD, you might be able to go for science to data science or the ASI fellowship, but they do require a PhD, so an extra 3 years of work. Actually, because of the number of applicants who already hold those degrees, you will be at a disadvantage when applying for those when you only hold a bachelor's, like I do. Now, as I said, starting date. The cost of education is not just monetary. At the moment, there is no way within the UK educational system to advance your degree, to do it faster. You have to plow through the 3 years if you're doing a bachelor's. You can do a PhD faster, you can't do a master's faster. So if you actually want to minimize the cost and pay lower tuition fees, you're not allowed to do that, because the admissions committee, the exam committee meets once a year, and they don't care that you want to get a job faster. So you don't get the flexibility. Your starting dates are later, and the industry is developing now. There is high demand now for data scientists. There may not be in 3 years' time. There might be a glut in 3 years' time. So purely from economical perspective, the cost of doing a degree is quite high. And obviously, there's also the question of getting funding for a PhD or getting a good advisor for a PhD. So not being forced to write on a topic that you don't care about and that maybe 2 people will read. And really doesn't guarantee improved career prospects. You might get a job, but you will be stuck in it for 10 years if you can't demonstrate your ability by things other than your degree. So how do you actually go about it? First of all, things not to do. Hope that a university degree is a ticket to a rosy future. We've already seen that it's not. Expect to do it all on your own. So people might assume that, okay, since I decided not to go to university, I just became a lone wolf, sat down with a book and just read and read and read and coded and coded and coded, and here I am now. First of all, when you're starting, you don't know what you don't know. You need feedback. One thing that defines good education and good educational outcomes is how much feedback you get and how frequent it is. Students who sit a test before they even start reading the material and are graded on it will then learn the material better as being scored by a subsequent test, compared to those who haven't had a test previously. So it's good to jump in at the deep end. It's good to understand what you do not know. It's good to go and do a hackathon, even if you're only a beginner, because then you will actually get glimpses of what professionals are doing. Universities do not tell you that. Moreover, they don't give you the state-of-the-art techniques until you get 3 years into your degree, into a PhD, when you're expected to gradually find it out on your own, sitting in an office, not talking to people. So don't expect to do it on your own. Not just from the perspective of understanding things, but also from the side of time management. When you're on your own, it's very easy to procrastinate. If you're sitting reading a book, you get your favorite shows comes on, you're going to watch the show for 2 hours instead of reading the book. If you're sitting and reading the book with a friend, less likely so. If you're due to present on that book to a group of 200 people the following day, maybe even less likely. So a good thing about not doing things on your own is that you have social pressure. You got social responsibility to stick to your goals. And generally, humans are very bad at sticking to their goals when they're the only ones watching, when they're the only ones assessing themselves. You need external input. Not allow for a margin of error. You don't, when you're starting a software development project on a novel, like developing a completely new product, how many of you have actually managed to do it exactly on time as initially defined? How many did not? Raise your hands. There we go. So do not expect it to be the same when you're doing self-education. It's a complex project. You don't want to, when you make a first estimate, multiply it by 3 and expect it to take this long. Similarly, when you're pitching to an investor and they see your financial plan, they divide it by 3, because people tend to be very optimistic about how long it's going to take them to do something and how much they're going to procrastinate, or how little rather. Don't burn your bridges. If you're jumping into a risky project, into a risky venture, realize that it's risky. There's always certain odds of you failing. Don't completely burn your bridges. Don't completely kind of tell your boss to go away and leave you alone and you're never coming back. Make sure to stay friends and to get avenues to be able to come back into your old industry should you wish so, or should you need more time, or should you run out of money. Always have a plan B, because everything that you're doing, the fact that you're hacking through things, means that you're taking a riskier approach. It's a higher payoff, but it's also a higher risk. And the more, the higher the reward, usually the higher the risk. So you are likely to fail, and you will fail repeatedly until you finally succeed. And when you finally get to interviewing, don't hope that the employer can read your mind. So you've learned all of these things on your own, but that you don't have a degree. You need a way of still providing this social signaling so that other people know that you're competent. Now I'm going to go through these points. What did I do in the end? First of all, set a realistic time frame. I put aside a year for this project, equivalent to a master's degree. I knew I was going to be most likely able to do it faster, but I had enough money to sustain myself for a year. And this way, I knew I didn't have to rush. I knew I didn't have to despair when I failed repeatedly until I finally succeeded. Don't trust yourself with sticking to deadlines. I didn't sit and read a book on my own. I didn't go and do a Coursera course and hope that I knew everything. I signed up to as many meetups as I could before I started my own. Then I started my own. Now I'm responsible for giving a presentation to 200 people looking expectantly at me. And it's kind of embarrassing if I don't know what I'm talking about. So this gives me deadlines. I joined my classmates at UCL for a study group on a statistics textbook, which is, by the way, the main text for the machine learning masters at UCL. So if you create a structure around yourself, then you're able to replicate what a university would give you. You create yourself deadlines, and more importantly, you create costs for missing those deadlines. Having a cost is very important. If you don't have anyone around you who will if you don't have a group around you that will penalize you for not sticking to your deadlines, there are services that allow you to make a bet, where you pay them money. If you don't stick to your deadline, they pay to a charity you hate, like Trump supporters. So if you don't learn data science, Trump will win. Make a study plan. So the first thing I did was scope the area of my study. Figure out what are the latest developments, when did it all start. Turns out it didn't start that long ago, even though the first neural networks were developed quite a while ago in the 60s. The computing power has only been sufficient in the past 4 or 5 years to do it on any kind of large scale. So we're all lucky there because there's still a lot of scope for growth. This is similar to what happened when the internet first started getting high speeds, when people suddenly realized that, oh, you can have internet on your mobile. What can you do with that? Apps. Lots of apps. So you need to scope what you don't know and make a study plan. Don't stick to it too rigidly because you will find out new things on the way, but at least you need to have an idea of how much you're going to have to cover and when the deadlines should be. Finally, prepare for uncertainty. You don't know that you're going to be capable of learning everything in the time you have planned for yourself. Some things will naturally be difficult. You will plateau sometimes. Sometimes you'll get stuck with code, or sometimes you'll get stuck with setting up your AWS server or installing Cafe on your laptop, whatever. Allow for these things. As with project management, when you're putting a new product, a new piece of software into production, there's always delays. This is exactly the same. As a project manager, luckily, I've suffered more than my fair share of that, even though it was in another industry. So I knew all too well that I can't plan to do everything exactly on time. So I allowed for twice as much time as I was expecting to spend. Willpower. Self-study requires willpower and being organized. Willpower is a limited resource. We are often told that, okay, you just need to try harder. Well, yes, you can try harder, but for a limited amount of time. You can't just go and sprint for 3 hours straight because your body is going to run out of energy, your muscle is going to run out of oxygen, it's going to stop working. Your body will refuse to keep on going and doing this. So your brain is exactly the same. You're not going to be able to exercise willpower to unlimited lengths. So you need to be able to measure how much you have and how much you can realistically spend per day exercising it. Don't expect to sit down and study for 8 hours a day if you've quit your job, because you won't. Studying is a much more intensive exercise. It's a much higher cognitive load than sitting and doing a task you're used to do. Don't expect to be able to do that. Allow for 4 hours. Do more if you can. External reinforcement and social cost of default. By the way, social cost of default is how they solved microfinancing. When lenders tried to implement micro-lending by lending to a single person, the defaults were skyrocketing. They were like 50, in the tens of percents, so 50, 60, 70%. Because if the person didn't pay back the loan, nothing happened to them. Well, they got told off by the lender, but who cares? However, when they started lending to groups of people, say 6 or 7 people, come together and lend some money to do a social enterprise or whatever, the default rates dropped to 2%. This is what you get with corporate lending for nice large corporations with millions of turnover. Why? Because if one person defaults, the other 6 have to pay their debt. Now, once you've got a social cost of default, you're a lot less likely to try and cheat, to try and not pay back your debts, because there's a high cost of doing that. You will be humiliated by your peers. Humiliation is a much better deterrent than losing money or even losing your job. Therefore, try to introduce as many deterrents as possible to not sticking to your goal. And finally, limit your choices. Humans are not good at dealing with multiple choices, especially when they're allowed to change their mind. They did a study where they gave people a choice of 2 images, 2 posters to keep. Now, some of those people just chose a poster and took it home. The other half chose a poster, and a week later they were allowed to change their mind and swap the poster. Now, when later on they were questioned about how happy they were with the choice, those who were allowed to change their mind were significantly less happy than those who were not. So you will need to, if you plan to transition, into a new industry, you will need to manage your mood. You will need to manage your state of mind, because if you get depressed, if you get disencouraged, you're less likely to continue. The happier you are with your choice, the more likely you are to have a good mood and have the energy to study. Therefore, limit your choices. Don't limit your uncertainty as much as possible, because you will have a lot anyway. So if you've decided to do something, commit to it. Do it for as long as you can, until you fail beyond reasonable doubt. Then you can change your mind. But don't try to just move between different strategies every single day. Oh, today I'm learning one topic, but maybe I should learn another one. So maybe I should learn regression, or maybe I should learn XML, or maybe I should learn Java, whatever. So if you keep changing your mind, it's not a very good idea, because it won't just affect your productivity in terms of learning progress, it will also affect your mood. Now, time management techniques. Pomodoro, who knows about Pomodoro technique? Okay, so insufficiently many. Pomodoro technique means that you set an alarm for 20 minutes, and you commit to working for those 20 minutes, and then you have a 5-minute break or a 10-minute break. That way you know that you're not facing hours and hours of work, because when you have a long project, the largest mental deterrent is knowing that you don't know when it's going to finish. This way you have manageable chunks. So you work for 20 minutes, then you have a break, then you reset the timer, work for 20 more minutes, then you have a break again. So one thing that it does, it prevents overworking. During the break, you get to stretch, you get to stand up, and you must obey by the rules. You can't overwork. You can't work for 30 minutes instead. You must stick by 20 minutes. And especially when you have a tight deadline, this is a very efficient technique, because it forces you to do something in those 20 minutes. You can't just sit down and look on Facebook. You have to be focused on your work. And it's only 20 minutes, so it doesn't hurt that much. And you know that you're going to have a nice break afterwards. Spaced repetition. Don't try to do hours, like 10-hour chunks of work in one go. Another example from education. When students learned for 3 hours straight before an exam, they performed significantly worse than when they learned for 1 hour or 1 hour over 3 days. In fact, to perform similarly to the 3 hours, they only had to spend about less than 2 hours time with spaced repetition when it was over a few days. So don't try to cram. It's not a very good idea. If you manage to space your practice over a few days, you will learn more and you will have to spend less time doing it. So why not do it? You'll get more time watching your TV series afterwards anyway. A value of sleep. When sleep deprived, you suffer. Your working memory suffers, your concentration suffers, you perform significantly worse. So it doesn't actually pay to sleep less in order to work more. That doesn't help. You're more likely your willpower suffers the first. This is one of the main problems with investment banks, where people work 9 a.m. to 2 a.m. hours. Because Dan Ariely is another researcher who does quite interesting projects. So he looked at how likely are people to cheat when they're sleep deprived. Turns out they're much more likely to cheat. So if you're looking at Excel spreadsheet, and in order to get a bonus, you only need to kind of tweak the formula a little bit. If you're sleep deprived, you're a lot more likely to do that. All of our bankers are sleep deprived. So when you're studying, you must sleep enough. It will maintain your mood, and it will also allow you to learn more efficiently. Every little counts. If you have a task that you absolutely hate, like the other day I had to apply for a grant. I hate applying for grants. I hate filling out stupid questions. I just don't do it. So in situations like that, 20 minutes might feel like too much pain with Pomodoro. So what you do, you reduce it to 5 minutes. Give yourself a time limit. Do as much as you can in 5 minutes, then you can just drop the task if you want to. In this case, you can continue. The point of this exercise is to get started, because once you've actually started, you feel that it doesn't hurt so much, so you just may as well continue it. But first of all, you promise yourself 5 minutes, and if it still hurts, you drop it afterwards. You may do another 5 minutes an hour later, but it doesn't feel like too much pain. And finally, kill your perfectionism. You're not going to be perfect. I'm not perfect. I started learning data science half a year ago. So I'm not trying to compete with Andrew Ng. However, I'll know significantly more than I did half a year ago. I can now teach people about it, and this has value. So don't expect to become an expert. Don't expect to be able to, I don't know, humiliate others, because then you will be humiliated yourself. So this is not just about expectation, this is about modesty. If you're modest, if you're not hoping to become a Superman with your knowledge, then you're likely to have much more realistic expectations, and you're less likely to suffer from perfectionism, which will kill your results. Perfectionism doesn't let you get started, because then you want to achieve so much that the fear of failure becomes too high for you to even try. Now, the N word, networking. Everybody hates networking, but obviously, since you're not doing a degree, you will need to somehow find your connections. You'll need to somehow find a job. And it's a lot easier to find work through your social connections than through applications online, because those applications are frequently sorted by an algorithm. If you don't have, and the algorithms will have features such as, does this person have a degree? Does this person have a PhD? No? Discard. You don't want to be sifted out by a dumb machine before you even get to talk to somebody. You don't want to cold call people. I've tried that. I worked at a recruitment agency for 2 months. It's not pleasant. And moreover, most people get annoyed and they tell you to go away in harsher terms. So what you do instead is you make friends. Now, to a lot of people, and we're nerds, by the way, so we're introverts. So to a lot of people in the IT industry, networking is not pleasant, because we've always been taught that we need to go and talk to people we don't really like about something that they're interested but we're not. And then when you go into a meeting like that, into a networking event, it actually doesn't work, because your body language shows that you're not interested in them, that you're bored. So the conversation stalls and everybody ends up kind of uncomfortable and kind of unhappy and no results. So the key to this is actually be selective. Don't try to please somebody. Try to find your in-group, a group of people who are actually interested in the same things as you do, and go from there. Because you don't have to start big. Obviously, don't go to Comic-Con and expect to find a job there unless you are, you know, a professional cosplayer. But try to find the group that belongs to, that is related to your industry, to data science in my case, and go there and make friends. Go to events that you're genuinely interested in and express your opinions. Raise your hand, pester the presenter, because then you are noticed. So you will start meeting the same people over and over, and you'll make friends, and you'll find jobs, and you'll get connections. So this is what I did. I signed up to a lot of meetups and went to every single one of them. And I was I didn't like all of them, but I liked enough to make connections and to meet people and to find people who I could learn from, who are practicing data scientists, who I asked about, oh, how do I build a boosted tree? I didn't know that at the time, but they told me. And all you have to do in this case is ask, because if you're in the right group of people, you get the right kind of support. And also, you start signaling belonging to the in-group. By the virtue of having seen you around repeatedly, people will assume that you belong, even if you don't share all of the characteristics of that group. Even if you're not a data scientist yet, if they've seen you at 100 meetups, they'll probably assume that you are. So they might come to you if they need a new employee, if they're looking for somebody. You signal belonging. This is the same thing that your education would signal otherwise. And if you don't have a degree, you need to signal it out by other means. It will also create positive reinforcement. So when you talk to people, first of all, you'll figure out what works and what doesn't. You'll be able to ask questions, but also it's pleasant. It's pleasant to talk to people if you find the group that you're interested in. The whole point of the exercise is not to try and be liked. It's to find somebody who you will like, because then they'll like you in return. Reciprocity. People will tend to show affection to those who show affection to them. And in any case, this is still work. You're not going to like every single meeting you're going to go to. You still have to get up and schedule them and go to them regularly, because once in a while you will get to one where you will meet somebody useful or somebody you will like, somebody who likes you. You get connections, you get jobs. But don't expect every single one to work perfectly. Just try to pick out the ones that sound good to you. And obviously, don't expect immediate results. You need to be seen multiple times. You need to develop your social skills until it actually clicks all of a sudden. And it will not take 1 or 2 meetups. It will take maybe a month, maybe 2. It depends on what your existing level of skills is. By the way, it's also a good idea to do things like improvisation classes. Anything that's allowed, or dancing classes, anything that makes you humiliate yourself or something that you think will humiliate you in public is good, because then you're desensitized to it. Then you're happy to go and talk to 300 people. Then you don't care about somebody possibly not liking you. Because otherwise, if you're really discouraged by every single negative comment, you might stop. You don't want that to happen. You want to desensitize yourself. So, resources. What did I actually do in technical terms? And I will post a lot. There, I have a very long list, which I will post on the Slack channel or possibly on the write-up for the on the presentation page on the PyData website. So, first of all, meetups, PyData, LMLP, my meetup, Science Journal Reading Club. Google them. There's a machine learning meetup as well. Go on meetup.com, enter machine learning, enter data science, and you will see that there are tons of those meetups, and they all meet quite regularly. You can very easily schedule 1 or 2 every single week and go to them. If you don't find any that you like, start one yourself, even better. I started my meetup 2 months ago. Now there's just under 800 members. So I get to talk to a lot of people. I get to pester people who visit my meetup if I have any questions. Kaggle and hackathons. As soon as you have the most basic knowledge, like for example, I personally started with Andrew Ng's Coursera course on machine learning. And I spent a month on that, and then the first thing I did afterwards was do a Kaggle competition. It was the Prudential competition, and at the point when I was starting it, I didn't know R at all. So I had to learn R. I did it by looking at what other people submitted in their code, understanding how it works, debugging it, getting it to run on my computer. Then when the code got too slow to run on my computer, setting up a Google Cloud server, Google Cloud virtual machine to run it for me. This is all learning. This is all things that you're going to have to do as a practicing data scientist. And don't be discouraged if you don't know something. If you don't know, Google it, copy somebody else's work, see how it works. Because textbooks will not contain all of the advice. Machine learning packages don't have very good documentation frequently, as you may probably know by looking at them yourself. So the best way to do something is to practice. If you can't find something on Google, then ask somebody. Ask the creator of the package. Ask on Stack Exchange. And people will answer those questions quite happily. This is how you write your own textbook. And this is by far the best approach because it closely approximates what you do as a working data scientist. And this is why you will get an advantage over people who learned via textbooks. Because when I'm reading elements of statistical learning, it doesn't tell me how to implement it, how to put it into production. It tells me about the statistics underlying the algorithms, and the authors tries to advertise the particular algorithms they came up with themselves, which doesn't work very well, but they like it. However, when you try to translate that into a career, it doesn't really work. It's a reference. Textbooks are a reference. Competitions is where the actual learning happens. Hackathons. Go find hackathons. Go to, there are some that deal specifically with Kaggle competitions. There are some that try to deal with open source data sets. For example, there was one at UCL where they looked at NHS data and tried to find correlations within it, modeling it, etc. So try to find as many practical events as you can and go to them. Because you will make lots of mistakes at first. You will be extremely slow. It will be frustrating, but you will be learning. And you will have to do that anyway, should you find work. Coursera. There's plenty of free resources. So Coursera has the Stanford course by Andrew Ng. It has a few others related to machine learning. Look at reviews. Look at what the course content is. Pick the ones that you feel are most useful for you. Udacity. Udacity has a course on TensorFlow, which has been recently published by, in cooperation with Google. So use those resources. They're there for you, and they're free. Know your stats. Data science is based on statistics. The reason why I managed to transition into data science so quickly is because it didn't take me that much time to learn the basic stats. But then I didn't remember them at the time I started. The last time I did statistics was 4 years before then, when I was in my year 2, and we had a lecturer who gave us notes, and we just filled out the blanks. I didn't even show up to half of the lecture, so I didn't remember it. I didn't know what gamma function is. But moreover, you will not need most of the university statistics, because at the moment what's taught at universities, even at a maths degree level, is frequentist statistics. And what you need for data science is Bayesian statistics. You need updating. You need to update your expectations as you see new evidence. And this is not covered by a lot of university courses. So books that I have looked at was Elements of Statistical Learning. It's a book by Stanford professors. An Introduction to Statistical Learning with Applications with R, I think by the same guys. A book on statistics by Janes, which I don't remember the title of, but it's very easily Googleable. I'll post it on the Slack or on the website later on. And finally, pester people. If you're lost, then find somebody to ask. This is why you need the networking, by the way. So if you're working on a project, then you go to a meetup, find somebody who might know something, ask them for their advice. They'll point you somewhere, not necessarily in the right direction, but it will move you off a dead spot. And this is all you need sometimes. And that's where you learn a lot faster than by Googling the wrong queries a lot of the time. And finally, read the white papers. So the blogs do not contain state-of-the-art. Competitions do not contain state-of-the-art. If you want to really understand where you want to get to, even if you don't get those papers at first, go to the top companies, go to DeepMind, read their white papers. What are they doing? Go to Facebook, look at what they're publishing on data science and machine learning. Look at the top people in your field, find out what they're doing so that you know where you need to get to. And also, read those papers repeatedly. First time you read them, you may not understand them. 2 weeks down the line, once you've practiced a little bit, you may understand most of the paper. Third time, you'll understand all of it. And this is, again, how you learn. Finally, don't get started. This might sound like controversial advice, but when you're embarking on on a complex project, don't just jump in. Don't burn your bridges immediately. Plan first. If you're a project manager who has to, I don't know, build an Eiffel Tower, are they going to decide, okay, we're starting tomorrow. I don't know where I'm going to get the steel from. I don't know where I'm going to get the builders from, where I'm going to get the machinery from. I'm going to start tomorrow, and I know the budget already. I haven't asked anyone. Don't do that. So it took me about a year of planning before I actually, well, slightly less than a year, but about 9 months of planning before I actually left my job. And I felt I was ready to embark on this. So make sure you know where you're actually aiming. This is the key that allows you to get there fast, because then you have the exact metrics by which to assess your learning. The same as you would assess a learning algorithm, you need to have a loss function, you need to have a cost function. How do you know? Because if you don't know where you're going, you don't know how far you've gone either. And yes, you need the right questions. Where are you going? So, question time.